Now in this lecture, we discuss cache memory. Now, whenever processor need any data, it will get the data from the main memory. But a processor is having high speed than the main memory. That's why processor always need to wait to get the data from the main memory. Now this is the obstacle towards achieving the good performance. Now to improve the performance, we need to introduce one memory which is smaller and faster. So that is the cache memory in between processor and main memory. Now cache memory always holds the currently active segment of the program and their data. Now, cache memory is based on the property of computer program known as locality of reference. Now, what is locality of reference? Analysis of programs indicates that many instructions in a localized area of program are executed repeatedly during some period of time. Now, if one instruction is being executed means what? Again, this instruction is going to be executed soon. That is nothing but what? Locality of reference. Now, if we take loop, the instructions may be the one in loop, nested loop, or few procedures calling each other repeatedly. Now here in this case, the instructions will be executed repeatedly. Now that is called the locality of reference. Now here two types of locality of references are there. One is a temporal locality of reference and another one is a spatial locality of reference. Temporal means what? A recently executed instruction is likely to be executed again very soon. Now, if one instruction is executed, then it is going to be executed soon. That is called the temporal. Now, coming to the spatial locality of reference means what? If one instruction is being executed means what? The instructions nearer to these instructions means what? Group of instructions are going to be executed soon. So that is the spatial locality of reference. Instead of only one instructions to be copied, now the group of instructions to be stored into the cache memory. Now here if we see, this is a processor and cache memory. In between processor and main memory, in between cache is inserted, and cache size is small and main memory size is large, and cache speed is as almost equal to as high as processor, and the speed is main memory speed is slow compared to the cache memory and processor. Now, whenever the processor need any data, it will search in the cache. If the data is available, then that is called the cache hit. If the data is available in the cache, then that is called the cache hit. If the data is not, and then at the time it will get the data, processor will get the data and execution takes place. If the processor is searching for data, if the data is not available in the cache, then that is called the cache miss. And now at the time, it will search the data into the main memory. If the data is not available in the cache memory, then the processor will search the data in the main memory. If that data is available, now the complete cache is divided into blocks. Block is nothing but what? A group of words together is called the block. Now if that word is available in any one of the block, that complete block, that word is given to the processor, and also that block is loaded into the cache. And because of the locality of a reference, if one instruction is being executed means what? That instruction and instructions nearer to that instructions are also going to be executed soon. By analyzing that, so block of instructions are moved into the cache. Now, copying this block of instructions into the cache is called as the mapping functions. Okay, loading or copying or moving this block into the cache is called the mapping function. When the cache is full and block of words needed to be transferred from the main memory, and some blocks of words in the cache must be replaced. So this is determined by the replacement algorithm. If a new block, if already cache is full, and if new block is needed to be moved from the main memory to the cache memory, now which block has to be replaced with the new block, that is decided by the what? Replacement algorithm. Now, already we have discussed the cache hit and cache miss. In that cache hit, again, read hit, read miss. write hit, write miss, different terminologies are there. Read hit means what? Whenever the processor want to read the data, if the data is available in the cache, then that is called the read hit or cache hit. We can call it both terms we can use. Now, if the data is not present in the cache, then that is called the read miss or cache miss. Now, in the case of read miss, now the read operation is not in the cache, then that is called the read miss occurs. And the block of words contain now, this is a main memory, and that instruction is in this block, then this block should be moved into the cache memory and that word should be given to the processor. But what happens now in the load through or early restart, that word is first applied to the processor and later that block is copied into the cache. So this is called the load through or early restart. So instead of wasting the time for loading the data, entire block should be loaded into the cache memory. That particular word is given to the sent to the processor, and later, if the processor is doing the execution, later this block is moved into the cache. So that is the early restart or load through. Now, if the processor want to write the data, then this is the processor and this is the cache memory and this is the main memory. If the processor want to write the data, so there are two protocols are there. One is a write to protocol and another one is a write back or copy back protocol. So whenever the processor want to write the data into the cache memory, at the same time, simultaneously, it will update the main memory. So both the cache and main memory simultaneously updated in the case of write through protocol. Now in the case of write back, only update the content of the cache. Now only in the cache the data will be updated and mark it as a updated by setting the flag bit known as a dirty bit or modified bit. So by using one flag, that flag is called as a dirty bit or modified bit. It will raise the flag so that it indicates that block should be updated in the main memory. And when that block is updated means if any new block should be copied into the cache memory, if that block is replacing this block, that time before going to replace, that block is updated into the main memory and then the new block is replaced into the cache memory. So the content of the main memory are updated when the block is replaced in cache. So this is called the write back or copy back protocol. Now write through means what? Both the cache and main memory both are updated means what? So unnecessarily it is copying the data into the main memory. If any modifications are taken place in the cache, again that will be done in the main memory. So unnecessary write operation is taking place in the main memory. Now coming to the write back, so whenever that content is needed again, the processor needed that content again from the cache itself, it will read. Now, before going to delete the content of that block from the cache, that will be updated in the main memory. So here the repeated times of write operations are avoided. Now mapping function. If that block is not available, if the data is not available in the cache, from the main memory to the cache memory, data is copied. Moving the data or copying the data from the main memory to the cache memory is called as a mapping technique or mapping functions. There are three different functions are there. That is a direct mapping, associative mapping, and set associative mapping. These three techniques we are going to study in the next lecture. Now, for that, we need to analyze the um, processor. We need to analyze the memory size and cache size. Now, how these blocks are divided, cache is divided into blocks and main memory is divided into block. Now, here I have taken this is the main memory and this is the cache memory. And main memory size is 64 words, total 64 words, sorry, 64 kilowords, and the cache memory size is 2 kilowords. Now always cache memory is a small main memory. Now this complete memory is divided into blocks. Complete memory is divided into blocks. Now here in this block is nothing but what? Group of words together is called the block. Now this block size here it is mentioned as 16 words. So 16 words we are calling it as a one block. And cache is also divided into blocks, and this block size is same as the main memory. Why? Because whenever the data is not available, that complete block we are moving into the cache. So here the block size and here the block size both are same. And here the block size is also 16 words. And here the complete cache size is 2 kilo, and here the complete memory size is 64 kilo. Now tell me, if the block size is 64 kilo and the total memory size is 64, then how many number of blocks are available in this main memory? Means how to do number of blocks in main memory is equal to total memory size of the total memory divided by the number of words, 16 words. If you calculate this, then you will get 16 ones or 16 fours. So total 4 kilo means what? 4 kilo is nothing but what? 4096. So that is nothing but 0 to 4095. Total 0 to 4095 means what? Total 4096 blocks are available. Now, similarly, in the cache, if each block is consisting of 16 words and the total cache memory is 2 kilo and the number of blocks in the cache memory is equal to 2 kilo divided by 16 words. If you calculate, then you will get the 128 blocks. So the first block is 0 and the last block is what? 127. So total 128 blocks are there in the cache. Now, if you have this knowledge, then with this knowledge, we are going to analyze these three mapping techniques in the next lecture.